Hello, I think this is number 9 now. We're up to number 9. And I was going to talk today about the soils, start really getting into it. But then I thought it's better first to explain what pH is about. Now, this is not something that you really have to understand if you don't want to, if you find it too complex. I'll try to simplify it as much as I can for those who are really interested. But if you find it too complex, don't worry about it. Just accept the fact that there is such a thing called pH, which measures either the acidity or the alkalinity of a solution, and that if it's below 7, it's acidic. If it's higher than 7, it's alkaline. So for those of you who are interested, there is a simple explanation. So as I said just a minute ago, a few seconds ago actually, that pH is a measurement of the acidity or alkalinity of a solution. Okay? So anything that is water-based has a pH. Whether we like it or not, it has a pH. Now, I don't know how many of you ever thought, why is it called pH, not DW or BC? pH stands for power of hydrogen. That's what pH actually means. What does power of hydrogen mean? Okay. Now, water is H2O. It's all water-based. The whole thing comes from water. So water is H2O. So in its molecule, you'll find 1 atom of oxygen and 2 atoms of hydrogen, H2O. Now, this water can break down. This H2O can break down according to this chemical equation. So H2O can break down to produce OH, which is called hydroxide, and H+, which is hydrogen ion. Now there's a difference between H and H+. H is hydrogen. H+ is hydrogen that has lost an electron. So what's really left out of this hydrogen atom then, if it's initially comprised of just 1 proton and 1 electron? Away goes the electron, so all that is left here is a proton. So a hydrogen ion is really a proton. And this is the acid component. This is the base or the alkaline component. So a hydrogen ion or a proton is actually an acid. That's the acid. That's why they call sometimes acids as proton donors. I don't know if any of you are on, those stomach medications, the PPIs. Well, I take them, sadly. PPI stands for proton pump inhibitor. It is, in other words, it's an inhibitor to acid secretion. You know, in science they like to give big names to everything rather than saying it simply. Okay. Now, this is the thing, if you are ionizing something, if you're getting something that has no charge on it, and you're producing from it 2 components, one with a negative charge and another with a positive charge, there has to be an electric balance. In any system in nature, to be stable, it has to have electric balance. If it doesn't, then it is unstable. Which really brings to mind some of those products, that you find these days. This is an ionizer. So what does it produce? They say to you, for example, it produces positive ions. Well, what happens to the negative ions? It's also producing. No explanation. It doesn't produce negative ions. Now, hang on. You cannot produce one without the other. You can't. It's impossible. Okay? So be careful. Be careful of these snake oils. There's many of them around. All right. So water can dissociate to produce 1 component that's alkaline and 1 component that's acidic. But the numbers are the same, so 1 for 1. So there's no net acidity, there's no net alkalinity, because these will antagonize each other. Now this only happens when you have water, pure water. If you have anything else, other than water, it's going to push the balance in favor either of the hydrogen or the hydroxide. So you'll either get more of this or more of that. And in this case, it will either be acidic if there's more of this, or alkaline if there is more of that. All right. The other thing is that not all water molecules will do that. Not all. Actually, only 1 in 10 million. So if you have a glass of water, you're looking at a glass of water, it will have billions and trillions of molecules in it, but only 1 out of 10 million will do this process. 1 in 10 million. Now, how many zeros 10 million has? 7. Okay. So the pH is a scale. It's a logarithmic scale that is easy to deal with. So rather than us saying the concentration of hydrogen is 0.000001% or whatever, we use this logarithmic scale, pH 7. The power of hydrogen is 7. Now, if this is the case, if the power of hydrogen is 7, then the power of hydroxide is also 7. Now, you rarely hear, like the term POH commonly used. It is used in chemistry, but not in day-to-day use. But POH also exists. So, POH plus pH is always equal to 14. They're only equal to each other when one of them is 7, then the other is also 7. Clear? I think it's clear. Now, because this is a logarithmic scale, when the pH goes down to 6, it means the acidity has increased tenfold. Between 6 and 5, it's another tenfold. For every single digit, the actual acidity or alkalinity increases or decreases by 10 times. Why 10? Because for this to be 6, then we will need to have 6 zeros, not 7. So 1 million instead of 10 million. Okay? Now, I have seen people who claim to be therapists who don't understand this. This is very, very simple, basic chemistry. In fact, you don't need to go to university to study this. In high school chemistry, they teach this. So there are people that go around and say that water is acidic or water is alkaline. And then you have something or another, this gizmo that will pump up ions in the atmosphere to change the ionic structure. This is not true. Chemically, it is not true. Scientifically, there's absolutely no foundations to these things. And when we talk about the pH, we have to understand that everything in nature that is based on water, that is in solution, has a pH. So our blood has a pH. Our blood pH is normally about 7.3, 7.4, something like that. Our urine has a pH. It's in the acid range. And that's something that's controlled by the kidneys. The kidneys don't only get rid of toxins, but they also make sure that your blood stays alkaline, so the acidic component is flushed away. Soils have a pH. The soil pH can vary quite a bit, depending on the region. But normally, agricultural soils have a pH between, say, 5 and 8. But you can find soils with a pH of 3 and even less, or 9 and even more. These will be very hostile, very difficult to grow crops in. Now, in Australia, normally the pH of soils in the eastern seaboard is acidic, and those inland are alkaline. I'm talking about Australia here. I know that there are listeners in other parts of the world, but there are certain things that I can use, examples out of Australia only because I can't talk about every part of the world. But normally, an area of high rainfall becomes acidic. Why? Because the rain leaches out the alkaline component and you're left with the acid. Areas with low rainfall are invariably alkaline, but again, this is not a rule. And the pH of the soil affects so much the availability of the essential elements and what you can grow on that soil, because some crops are tolerant to a certain pH range and not another. Well, this is all for today. It's a short presentation, but I think it's important for those who are really interested to know what the pH is, to understand where it comes from. But if you find it too complex, don't worry about it. We'll just jump into the next subject later on. Thank you for listening.